Let us understand an important phenomenon which is called as atmospheric refraction. We know that refraction means bending of light, correct? So refraction is when a light entering from rarer to denser, it bends towards the normal. It won't go straight, it will bend towards the normal. Slightly it will bend, correct? From denser to rarer medium. This part is very, very important. Okay. Now, what do I mean when it comes to atmosphere? The earth, the closer the earth's atmosphere, denser the medium is. Okay. Closer to earth, it is dense. As we move away from earth on the atmosphere, it gets rarer. Okay. On a high altitude, it becomes rarer. Low altitude, that is close to earth, it is denser. So rarer to denser we are entering. Okay. So when the light enters from rarer to denser media, rarer to denser, it turns towards normal. Okay. Same way when it enters from denser to rarer media, it goes away from the normal. Rarer to denser towards the normal, denser to rarer away from the normal. Okay. So now in atmosphere, what is happening here? It is actually entering from rarer to denser to, so it will naturally move from towards the normal, right? So let us understand this. Stars, what happens to stars? This is the real position of the star, and the light ray emitted from star is entering the atmosphere. It goes straight until it comes to in contact with the atmosphere of the earth. This atmosphere is denser. Outside it was rarer, this is denser, so it bends towards the normal. It bends so much that because there are multiple layers of refraction, so the person seeing from here, actually it comes like this. When it is projected back, the person feels the star is here, whereas this is actually the real position and this is the apparent position. Apparent means not real position. So the person thinks that that star is here. Okay. So this is due to the atmospheric refraction. Now, since there are multiple layers in the earth and each of them differs in the density, they don't have the same material. It keeps on changing. So refraction keeps on changing because of the density of the atmosphere changes. Refraction also changes. So it keeps on changing. So the star look like it's twinkling because the light, when it is too much refraction, we will get less light. When there is a lot of refraction, again we get more light. So the rate of the light entering our eye keeps on changing. That's why we see them as twinkling of stars. Okay, due to atmospheric refraction. Okay, this is the first point. Same concept is applied in advanced sunrise and delayed sunset. Now what happens here? The sun's real position is this. This is the horizon. Okay, this is the horizon means our normal eye can see this level. We can't see beyond this. Okay, so the sun ray is entering like this. It was supposed to go like this, but due to atmospheric refraction, it bent towards the normal, and the person standing here actually sees the sun because of atmospheric refraction. When this is projected back, he feels that the sun is here. So this is in advance, it is appearing here, although it is not here, it is here, but it is appearing although the sun is already rising, correct? So that's why we see it in advance, 2 minutes advance we'll see. The same thing happens with the sunset. Suppose let us assume the sunset is happening now. In sunset, what happens? Sun has already set, but see here, sun has already set. Sun is already here, but due to atmospheric refraction, we still see the image of sun here. The person standing here still sees the image of sun here. That's why it is called as delayed sunset. So the difference is approximately 2 minutes. Okay. So advanced sunrise, before the sun has come to horizon, we see the sun, and even after the sun has gone, we still see the sun. This is due to atmospheric refraction. Atmospheric refraction. This is the main thing. Thank you.